Welcome to Engineering Practical Lab. This time around, we want to discuss about Zener Diode. Zener Diode. This diode is highly doped PN semiconductor materials, so that operate in reverse bias condition. Though it have two conditions like PN diode, forward bias and reverse bias, but its own major operation is at reverse bias condition, because at reverse bias condition, when voltage is increasing, it will maintain constant voltage. That's its own feature, that is its own characteristic, maintaining constant voltage. Even if you start increasing the source voltage, it will maintain that constant voltage. That's how it's been designed. So, and look at the diagram. It has the symbol, it has its own symbol, which is, and it has two terminal like other diode. It has anode, positive terminal, cathode as the negative terminal, and it operates in two conditions like other diode. So in forward bias condition, so when we forward bias this diode, that is when we put our source, let's say we have our source, this is our source. So let's say we have a source, so we have our source, voltage source, like this is positive and this is negative. So if we forward bias this diode, when we put positive terminal to the positive of the diode, negative terminal of our source to negative of the diode, this is forward bias condition. It will operate like PN diode. It will allow current to flow, and current will be increasing as the voltage is increasing. That's one of the conditions that it behaves like PN diode. So, but when we reverse bias it, it behaves differently. When we reverse bias Zener diode, it has a well-defined reverse breakdown voltage, at which it begins to conduct. It will conduct current and continue to operate continuously in reverse bias condition without damage. It will still, unlike PN diode, that when you reverse bias a diode at a particular voltage, at a reverse voltage, it is going to break that, it's going to damage that diode. But this Zener diode will not damage at reverse bias condition. Instead of damage, it will maintain the voltage. It will not allow, even despite increasing the current, it will maintain that current even if the voltage is increasing. That is when we reverse bias the diode. Then when we interchange the terminal of a Zener diode now, let's say we put the negative terminal, we connect it with the positive of the diode, the positive to the negative of the diode, when we reverse bias a diode like this. So when a particular voltage is reached, which is what we call Zener voltage, it will maintain that voltage. Let's assume that the Zener diode is designed to operate at 20 volts. So once that 20 volts is reached, so even if you increase the source, let's say we have 20 volts and 20 volts is, if you increase the source voltage to 40 volts, so that 40 volts it will not affect the output, the output current, the output voltage of the Zener diode. It will still maintain that voltage. It will not allow higher voltage to it will maintain that voltage. It will not allow the higher voltage to get to the output. That's what it means. So it operates at the forward bias condition like PN diode, but at reverse bias condition, it will maintain that voltage. It will not allow higher voltage. It stabilize voltage at reverse bias condition to not allow the diode. It will not allow higher voltage at the output of the diode. This diode is majorly used for voltage regulation. That's the major function of Zener diode, for voltage regulation, to maintain constant output voltage. Do we have some equipment that require constant voltage? So the circuit design for such equipment, so we need this type of diode, so that we are going to have constant voltage, such as our speaker. So our speaker require constant voltage, so in such a way that it will give us require output. So when our output will give us, our speaker will give us required output when it has constant voltage. Once there is change in voltage, so there will be distortion. So for us to have that constant output from speaker, so we need a constant voltage, and the circuit, in that circuit it will require this type of diode, which is Zener diode, to maintain constant voltage. Likewise, we make use of it in our AVR, automatic voltage regulation. That's our stabilizer. So we use it, we find it useful in stabilizer circuit. So that whenever we have high voltage from the source, so the output will maintain that specific. Let's say, for example, now if the diode used is maybe 200 volts, 200 volt diode. So, and let's say from the source, from NEPA or from our generator, our voltage increased to 250 or 300 volt. Our voltage increased to 250 to 300 volt. Instead of that higher voltage to come out to come out from the output and damage our equipment, our TV, our radio, our home theater and all that, instead of our fridge, instead of all those equipment to get damaged. So the AVR will not allow this higher voltage to come at the output. So it's going to maintain that voltage. That's the major function of Zener diode, is to maintain voltage regulation. And any circuit that require constant voltage, we will find Zener diode to be useful there. This diode is very, very useful in any circuit that require constant voltage. If you look at electronic components, there's one we call thyristor. Thyristor is used in our electronic circuit to maintain constant voltage as well. So that it's used to as a safety device for our electronic component. We use it for safety device in our electronic component to maintain our electronic component voltage. So we use thyristor. Instead of thyristor sometimes, you can see you can use this diode as well. Zener diode can be used as well instead of thyristor. You can use Zener diode or instead of thyristor. So you do the same, you can perform the same function. And Zener diode has voltage rating. It also has power rating. So even if we have a diode is been designed to have specific or to carry specific voltage, so it also have power rating. If the power rating is higher than the source, so it can get the diode damage. So that some of you might think, so far we have Zener diode can maintain constant voltage. While sometimes it's used to get burned, even our stabilizer will get burned. So if the power rating of the diode is higher than the power rating from the source, it can get the damage. It can get the diode damage. It can get burned. But what it does is that it maintains constant voltage, so that we don't have over voltage at the output or over voltage in our component. So in our equipment, there will not be over voltage. There will be constant voltage, so that our equipment will not get damaged. And if you look at this Zener diode, let's look at the diagram of Zener diode. Let's look at the picture. Let's see how it look like. This is Zener diode. This is how it look like. Most of it look like this. It look like this. Zener diode. These are Zener diode. So it has positive and negative, just like PN diode. You can see this black mark is negative. This is our cathode. This is anode. Likewise, this place is a little bit dark, black. That's negative cathode. This is anode. So this is like this. This is our. Though we have some that look like PN diode. It look like PN diode. You know, I've shown us PN diode. Let's see. Let's check if we have. Okay, we have PN diode here. We have some Zener diode that look like this. They look exactly like this. But how are we going to know the difference between diode that look like PN diode? So how are we going to know the difference between this kind of diode and Zener diode? The difference is that they have numbers. They normally write number on their casing. something like this, there will be number. So in Zener diode you have different number, but in also PN diode, that one also have its own number. Like in Zener, you have something like 1N4728. 1N4728. Anytime you see something like this is Zener diode. But if it is PN, is 1N4007 or 4001. It's like 1, it's going to be 7. So anytime you see a diode that look like PN but it's Zener, so because when you see a number on a diode and you see that 1N4007, that means it's not Zener, it's PN. But if you see something like this that look like PN, then you look at the body, it's written, you can see that something is written on the body of this one as well. So, and if you look at that number written on the body of something like this and you see something like 1N4728, it's not PN, it's Zener. But though Zener have its own feature, Zener is like this. Zener is normally look like this. Even big one, small one, it's look like glass. This is the picture of Zener diode. Smaller one, bigger one. This one is like 0.5 watt. We have one thicker one, 1 watt, 2 watt, depending on the power of the source that we want to use it for. So it has different power rating. But this one is smaller one for smaller circuit. It's like 0.5 watt circuit. You can use this one. But sometimes we might need bigger Zener diode, bigger one that have something like this, that have this capacity like 1 watt, 2 watt. So, but for us to know if it's Zener or PN, we'll look at the number written on it. If it is something like, no, we have different number, not only this one, not only this one. Even that PN can be 1N4148. It can be 4148. When you see 4148, it's PN. 1N4148. But 4733, anything 47, anything 47 is Zener diode. This is Zener. These are Zener. These are Zener diode. Zener. These are Zener diode. Oh, this one is PN diode. PN diode and Zener diode. The number written of them is different. So if they look alike, but anything you see 4733, 4728, those are Zener diode. Zener diode that look like PN diode. It will be 1N4728, 1N4733. These are Zener. What is PN? You see something like 1N4001 or 1N4007. So something like this. This one, if you see something like this is PN. So for PN and Zener that look alike, you will see number there. So you see, you can get this number from data sheet of that. If you see a diode, I don't know, maybe it's PN or Zener, write that number. Go to your phone, type data sheet of that number to tell you if it is Zener or if it is PN. I'll still give us more numbers of Zener and PN. So later at the end of this video, I'll give you. You'll see different numbers that we can use to know if it is PN diode or Zener diode. Let's check the difference between PN and Zener diode. Let's see the difference between PN and Zener. So PN operates in forward bias. PN diode only operates in forward bias only. It will not operate in reverse bias because it will get damage. If the current continues to increase at reverse bias, it operates in forward bias. PN and Zener, they are different. So this one operates in forward bias. When you forward bias, that's where it will operate in forward bias. In forward bias. So it operates in forward bias. Why this one operates in forward bias? Zener operates in reverse bias. This one operates in reverse bias condition. So that's why most of the circuits that you find Zener, they connect it in reverse bias in all the circuits that they want to use it for. because they expect it to operate in reverse bias condition. In reverse bias condition, even if you continue increasing the source voltage, it will maintain the output voltage. The voltage will not increase, so that at the output it's not going to give us higher voltage. It will maintain to stabilize the voltage. And this PN diode normally gets damaged at reverse bias condition. At reverse bias, PN normally gets damaged. It will get damaged, but this one will not get damaged at reverse bias condition. Reverse bias. At reverse bias, it will not get damaged. It will operate very well. It will look good at reverse bias condition. It will operate normally at reverse bias condition, but this one will get damaged at reverse bias condition. That's the difference between the two. So at reverse bias condition of this one, the voltage will still be increasing, but at reverse bias of Zener diode, it will maintain constant voltage at reverse bias condition. At reverse bias, the voltage will be increasing, but this diode will maintain constant voltage at reverse bias condition. That's why most of the circuits that will have this diode, they will connect it in reverse bias condition. So it's different from PN diode. Now let's look at the graph of this diode, Zener diode. Let's look at the VI characteristic of Zener diode. So just like PN diode, it has forward bias condition and reverse bias condition. This is forward bias condition. These are the reverse bias condition. At forward bias, it behaves just like PN diode. The same way PN diode will behave. It will behave the same way. When it reaches particular voltage, it will start conduction will start. It will conduct, and it will continue allow current to flow. But at reverse bias condition, if it is PN, you are going to have leakage current. At the it will start small current will be coming. At the particular current, breakdown current, it will do what? Breakdown voltage, it will damage that PN diode. But if it is Zener, it will not damage, it will maintain constant voltage. This is what we call Zener breakdown region. This region is Zener breakdown region. That is, even if you continue increasing the voltage, so it will not at a particular point that voltage will not increase again. It will maintain constant. Though current will continue increasing, but that voltage will to maintain the constant voltage, so that higher voltage will not come out at the output of that of the circuit. So this video, for it not to be too long, so this is what we can discuss here. But there's a note at the description page of this video. Click on the link. You're going to see the note. So that note will give you more insight, more knowledge. So what you're supposed to know about Zener diode as an engineering student. Thank you.